So chemistry, the study of matter and what? The changes it undergoes. Okay. So I guess the next thing we should define is what? What's matter? Yeah. Can you guys give me a definition for that? I mean, I could talk all day long, but I want to try to involve y'all, okay? So when you come to the sessions, expect a little bit more interactive approach. I want you guys to be a little bit more proactive and have a little bit under your belt, okay? So this is the first one. I don't mind guiding you along, but matters anything that
has mass and
has
space.
Perfect. Anything that has mass and takes up space. Okay. So there are three phases of matter that we should know, right? What are the, well, there's more. They're coming up with random ones, but for all intensive purposes, what are the three main states of matter? Texas and Oklahoma and Louisiana. What are they?
Solid, liquid, and gas.
Sure. So I try to do a funner approach to tutoring. I can be serious monotone guy if you guys want me to, but I think you'll find after 2 hours of chemistry, sometimes you'll tend to tune out. So I might do some bad jokes or accents. If it gets distracting in any way, shape, or form, let me know, and I will gladly, quit doing it. Okay. But if not, then I shall continue. We're going to become very familiar with each of these phases by the end of the semester. We're going to look at things that are mixtures. What's a mixture? It's just a combination of two or more things, right? And there's a couple different types of mixtures you'll encounter: homogeneous and heterogeneous. So what does homogeneous mean? Well, homogeneous means that there is only one phase. Oops. So whenever I mix ice, when I make iced tea, I take the tea and the water and I create this liquid, right? That's brown. It's one phase. Do you understand what I mean by that? So when I pull out some of that liquid, it's a brown liquid that's mixed the tea and the liquid water as one new entity, one mixture. Does that make sense?
Yes.
Oswaldo?
Yes.
Okay. So the difference is if I have a heterogeneous mixture, they remain separate. So can you think of any real life examples that you might have encountered that in?
Cereal and milk.
Yeah, that would work because unless you get the cheap cereal and then it kind of melts into the milk. But yeah, that would definitely work. Can you think of anything else?
Oil and water.
You guys, very good. That's what I was looking for. If you've ever done any cooking, those two things don't go together well. And what will happen is we'll get two separate layers, right? One will be on top of the other, which there are distinct phases and identities of substances retained. Okay, let's see, what else do we need to talk about? Okay, let's talk about properties. I'm looking for a 3-bedroom property. Can you help me out? There's physical properties and chemical properties. Can you give me an example of a physical property? Let's talk about what it is then. Maybe it'll help. So physical properties is anything that can be observed without changing what you got. Give me a obvious one. You look
an
at something.
mass, maybe.
I'm sorry, I didn't hear you.
An object's mass. Or weight.
Yeah, you could, without changing it. Yeah, sure. How about the color? Right? Is boiling point one? Melting point?
Yes.
Yes, it is. Okay. You might be going from one state solid to liquid, but it's still water, right? You're not changing the substance. Okay. Density. Okay. Let's look at chemical properties. Sorry if you can hear my kittens in the background. So here we're going to be looking at properties in which something is going to actually undergo a change. So there will be no way to go back to original substance. Okay, can you think of any examples of that?
Maybe flammability.
Sure, you're going to induce a pretty big change there that you can't go back to. Right? You burn something, unless you're a magician, you're not going to be able to go back. I'm going to ignore that call. Anytime you cook, right? I think the book uses baking cookies as an example. You can't go back to cookie dough once you've cooked the cookie, right? Or the cookie dough. Let's look at extensive versus intensive properties. Do you guys know the difference between those?
No, I don't.
It's okay. Don't feel bad. That's part of what tutoring is here for, to let you know what you need to work on and what you know, what you don't know. So extensive properties are dependent on amount present. So give me an example. Mass.
Would volume be one?
Volume, good. Any of those things we got to measure, right? Intensive property is the same regardless of how much we have. Density is a good one for that one, right? So whether I have 10 grams of steel or 100 grams of steel, provided it's the same alloy composition, then, well, actually steel, pure iron. I think steel is a combination of iron and something else. Anyway, I'll get back to you on that one. But it's usually the same density. Do you guys know what density is? How do we measure density? Density is...
Was it with volume?
Volume is
Volume
inversely
mass?
proportional. Good. So density is directly proportional to mass. That means it's in the numerator, and inversely proportional to volume. That means it's in the denominator. Okay. And that's an intensive property there. So these are some things that you're going to need to memorize. So let's bring them. Okay, so the first thing we're going to do is we're going to look at the SI units for the different measurements. This table, make use of note cards. Quizlets is great for this. You guys ever been to Quizlets.com?
Yeah.
Okay, so know the SI unit, okay, for these base quantities. Some of these you probably won't worry about, candela, but then you're going to need to know these and be able to convert from one to another, okay? And I've got a conversions video that I'll send you and some quizzes and answers and all that. And I've got some tips and tricks that I'll show you to avoid some of the common mistakes I've seen students make over the last years. I'm an old man. I've been doing this for a long time. But for now, what I need you guys to do is to memorize these. Have you guys already started?
Yeah,
By
we looked at
chance?
some of it.
Okay. Now, I'm more interested in you knowing the relationship to the base unit, right? So if we're looking at mass for grams right here in the middle, so knowing that a kilogram is 1,000 times more than a gram, okay, and a milligram is 1,000 times less than the gram. So it's 10 to the third orders of magnitude difference. Okay, both of those are 10 to the third. Know which one's bigger and which one's less. And I'll show you a way to convert without having to worry too much about, hey, do I use negative exponent or decimals or what's going on here? Okay, so you should be